Hello everyone. Today I'm going to show you how to construct high quality electronic block diagrams. Now, what are electronic block diagrams? I'm sure you know what is a schematic diagram. If you have made a PCB or worked in electronics even at a small scale, you know what is a schematic diagram. Electronic block diagram is something similar, yet it is a little bit more simplified and it allows you to reconstruct the circuit by looking at that diagram. Now, the difference is electronic block diagrams are used in textbooks. They are used in high quality documentations or presentations, and it is a convenient way for the reader to understand what the circuit is and how to reconstruct the circuit while also retaining all the details of that circuit with a level of simplicity compared to a standard schematic diagram. The keyword here is high quality electronic block diagram. So high quality means that you can use these block diagrams anywhere that is professional, whether it is your documentations, whether you are writing a textbook, whether it is for your presentation. It will be high quality. That means you can zoom in however you want. You can project it to a very large screen and it will still remain in the highest quality. This is different because there are certain softwares or websites to do the same. There are two issues with that. Number one is either they are behind a paywall, or number two is they are not that high quality. So to resolve that, we are using a software called Inkscape. Inkscape is a free open source vector graphics editor. If you are unfamiliar of the software called Inkscape, think of it like Adobe Illustrator. It is again a vector graphics editor, but it is free of charge. You can start by going to the link on this what you see in the screen here, or else you can go to the link in the description and download it for your preferred platform, because this is available not only for Windows but even for Linux and Mac OS. So step number one is download Inkscape for your platform, install it, and then we will see how we can construct a high quality electronic block diagram. So when you download, install and open Inkscape for the first time, you can select a new document and this is the screen you are going to see. In this video, I'm not going to do a walk around of each and every feature or element in Inkscape. I'm only doing the application part of constructing electronic block diagrams. However, if you want me to do a walk around, please let me know in the comments below and I will do a separate video for it. Now, to construct electronic circuits, you need one thing. You need symbols. There are two options for you. Either you can construct the symbols yourself, just you can do that on Inkscape, or else find a freely, readily available library of electronic symbols. Now that is what we are going to do today. If you Google it, you can find a few out there, but I'm using one that is on GitHub and I will link it in the description below. So the next step is for you to download that and then double click on it in order to open it. Once you open, you will see something like this. Now this is all the electronic symbols that you will probably need to construct any kind of simple or complicated electronic circuit block diagram. Now you can zoom in by holding the control key and the scroll wheel, and why this is high quality is, once again, you can zoom in however you like and the quality still retains. Okay, so we are starting with this, and you can move around the canvas through the by clicking the middle mouse button. So we are using the symbols of the library, but we are not going to directly construct the block diagram here. So we are going to go back to the new window that we created earlier. But first you need to gather and copy the components or symbols that you need for your circuit. For this demonstration, I am going to construct a LM311 comparator circuit for a proximity sensor. where I have a variable resistor to control the sensitivity of the proximity sensor. So that is the circuit that we are going to construct. So for that, you first need a few components and you need to copy them. So assume that I'm constructing the circuit for the European standard. That means I'm using the circuit symbols for Europe, not America. So the first step is you can zoom in. Okay, I see a resistor here. I can copy it and then I can paste it in the new window. You can click multiple sections using the shift key, like here. Okay, now I have selected both the LED and the resistor. So the next step is to select all the required components and you have to copy them. Okay, it's like this. So for example, the resistor, you can just select on this resistor here. You can right click, copy, or you can hit Control C and you go to the new window and you hit Control V. So in the new window, when you hit Control V, you will see something like this, the resistor. So you need to do it for all the components that you need to construct your circuit. That is the next step. So not just the symbols, you need to copy certain other elements. For example, if your circuit has nodes, okay, you have to copy these as well. Okay, I'm sure in Inkscape you can draw circles and etc. However, in order to maintain consistency, it is better and this library recommends you to copy all the elements from this library. So I'm going to select nodes by holding the shift key and also the line. This line here, this is for wire. Okay, so you can copy that and also the text. So there are two types of text here. One is for 12p and the other one is for 8p. It is your preference and you can see with the subscript as well, like R1, R2, L1, C1. So I will select the smaller font size of 8p and for normal text I will copy this and then I will copy R1 symbol if I need for resistors and then I can copy the voltage also, maybe let's say 5 volt. I can copy that and also the necessary symbols. Now here you can see you have ohm symbol for the resistor value, so you can copy this symbol as well. And like that you have to go around this huge canvas and see what are the elements that you are going to need for your circuit diagram. So once you copy everything down to your new canvas, what you need to do is arrange everything in a corner so that whenever you need it, you can drag it from that corner. That is next step. Then most importantly, feel free to save this. So you can click file and you can click save as. Don't change the format. Keep it in the default SVG format and save it. And then we need to do some alterations to the default view in order to make things easier to construct the block diagram. So first thing is we need to have a grid, because if we have a grid, it is easier to get a reference on where our lines are going to be. So we can click view and you can see this option called page grid. So when you click view and enable page grid, you can see here there were a bunch of grid lines just appeared here. You can resize the grid if you want. All you need to do is click file and from file there is something called document properties. Okay, when you click document properties, you are going to get a separate window like this. In this document properties, you can go to the grids option here and then you can enable and disable the grid, and then you can actually enable the snap to visible grid lines only option, where when you are moving it will snap into a grid line. And here you can actually the spacing x and y, you can change the spacing. So you can change the units. Okay, if it is pixels, it is like this. So it is set to 1 millimeter by 1 millimeter currently, and if you want you can change it by using the plus and minus arrows. Next you need to have the option to snap. So there is another menu. You need to enable it through view and then there is something called, when you go to show height, you have to enable snap controls bar. When you enable snap controls bar, on your right, top right corner, another option appears like a magnet. This is to enable and disable snap to grid. So these are all the prerequisites that you are going to need in order to construct the block diagram. And then you will see how easy it is. So you can select this resistor and you can see how easy it is to move, and it will just snap onto the grid, and you can align everything perfectly along the grid. The next step is to just arrange the components the way you want. So you might probably have realized that we are using a comparator called LM311. It's an IC. However, we don't have the symbol or the uh, outline for an IC. That is because the default library does not have one. And typically, when you are drawing a block diagram, you don't need it. You just need a rectangle. If you have a rectangle, you can just indicate the pins that you are going to use in that IC, and that is your IC block diagram. Okay, so we are going to construct that. So first of all, I will take this. This is my line. Okay, for the wire, so anything I can use it. So I can duplicate it. You can press Ctrl D or Ctrl C, Ctrl V to duplicate it depending on how you like it. And here I am going to have my IC. Okay, let's say I will snap into a clear grid here. Okay, and maybe I want to reduce the length here. So reducing the length is very easy. So you zoom in, okay, like this. Double click on it. When you double click on it, you can see there's a red color line and a small diamond shape handle appears. So you can click that, and you can hold the control key in Windows. You can hold the control key and it will snap into the grid. So why you are holding the control key? Because control key makes sure that you are snapping it into straight lines. Okay, because otherwise if you don't hold the control key, it can go anywhere and everywhere, but if you hold the control key, it will stay straight. Okay, so I will, I'm pretty happy with this. Okay, and then again I will duplicate it, but right now I want to rotate it. So how am I going to rotate it? So in the second row of the menu bar, okay, this is the first row, this is the second row. You can see there are options to rotate. Okay, rotate counterclockwise. You can see the options to flip, blocks horizontally, blocks vertically. So I will just do it like this. And since you will see how easy it is, because we have enabled the snap icon, snapping part, it will just magnetically attach it together. And maybe I want this to be a little bit longer. Okay, maybe I can snap to this grid. Okay, and then I will once again duplicate it. You can of course use your arrow keys. Okay, and this is snap, and again I will duplicate it, Control D, and it snapped right here. Okay, this is, you can see, this is the outline for the LM311 IC. Okay, and then if you want, you can put text. So I will take a duplicate of this. Okay, and I will put here. Okay, have it here, and you can double click on it and you can change the text, and I will say LM311. So this is the text for LM311. And then you just need to define the pins. Okay, you just need to define the pins. Now when defining the pins, once again, you typically don't do the connections for the pins that you are not using, but generally you can label all the pins that you want. Since this is an 8 pin IC, we can have now 8 numbers. But if it is a larger scale IC or a microcontroller such as the such as the Admega 328P or a PIC microcontroller, just indicate the pins that you are using for the circuit. Do not include any unnecessary pins. Do not even write their pin number because it is not important. All the whole purpose of block diagrams, electronic block diagrams, is to give the user a simplified overview of your circuit diagram in order for better understanding and for reconstruction. We don't need unnecessary information. So please omit all the unnecessary parts. So then I will take a duplicate of this, and then I will have the pin numbers. So starting from pin number 1, of course, you can go with equal spacing. Here I will have like something like this. Okay, 2. Okay, so the 4 pins are laid out here very nicely, and I can just select all the letters, numbers, and duplicate it and move it here. Once again, you can, it's very easy. And here I will do the renaming 5, 6, 7, and 8. So you can make sure that everything is symmetric. So it looks like everything is symmetric here. And this is your IC. So it's very easy. You don't need to download or search for it. By the time you search for something like this, you can probably construct it within a matter of just a few minutes. And now we will construct the circuit. Now for this purpose, now for the actual circuit, we need a IR LED, and also we need a IR receiver, emitter and a receiver, which I have prepared earlier. So I will skip right to that part. Okay, so this is my IR emitter and receiver configuration. This entire thing is like a TCRT 5000. You can buy it off the shelf, which contain both of these together. But for accurate illustration purposes, we have to use the appropriate symbols, like where you have an IR emitter and an IR receiver. So that is why I'm going to use it. Or else you can even have a block like the LM311 called the TCRT 5000 and have the positive and negative terminals accordingly, right? And the other key thing is, now here we have individual elements. If you take the LM311, but when we are moving it, we need to move everything together. So it is very annoying to select everything and then move. So what you can do is, you can select everything once, right click, and you can actually group them. Okay, or else you can select everything and press Ctrl G. When you press that, now I don't need to select everything, it is already grouped, which is very convenient. So now I'm going to start developing my circuit. Of course, I will first snap my LM311 IC to somewhere more prominent, and then here also I will group this, and I will put it aside for now. And the configuration is, so pin number 1 we have to connect to ground. So it's very easy. So we already have the ground symbol here. Okay, so you can take this ground symbol and put it near pin number 1. Okay, and then you need to have the line. So this is where the wire, so you can draw a line, but it will not be fully compatible with it. So you can actually use this line which is there in the library, and once again you can double click, hit the control command, control key, and get a straight line. Okay, now I have grounded my first pin, and then I have to connect my 8 pin to VCC. Okay, I have to connect my 8 pin to VCC. So what I can do is, I can take this text and I can rename it as VCC. Or else, if you want to have a voltage source somewhere, like if you want to indicate it, you can go to the library and get the appropriate symbol for the voltage source. So I have renamed it as VCC, or else you can have the voltage source directly called plus 5. So whatever is appropriate you can use. Then in this case I will actually use the VCC symbol. Once again I will place it where appropriate, and then I need the wire again. So since I have a shorter wire, I will duplicate it here and I will bring it across. And this is my VCC. So by looking at it, it's very straightforward. I can say that pin number 1 is going to ground and pin number 8 is connected to VCC. And now let's build upon the rest of the circuit. So this is the entire circuit. So as you can see, pin number 1 is connected to ground of the LM311 comparator. Pin number 2 is the output from the IR receiver side. And this is the circuit for the IR emitter and receiver. Then pin number 3 is connected to the variable resistor, and the output of the variable resistor is the pin 3, and then either end is connected to the ground and VCC. Pin 4 is connected to ground. Pin 5 and 6 is not connected to anything. Pin 7 is our output pin, which is connected to the LED, and we have to have a resistor. So I will include that resistor right now. And then you have the pin number 8, which is VCC. So this is our entire circuit. So once you are happy with the circuit, all you need to do is export. So for that you have a couple of ways you can export. First of all, you can export this entire page, or else you can export this selection. So the easiest way is to export this selection. So you can just select the all the components of the circuit, then you can go to file and click export. When you click that, a separate window appears to your right hand side. This is the export window. And here, first change I like to make is increase the DPI from the default to 300. It gives a better quality. Then on the bottom right hand corner, you can change the format to anything that you like. Typically, if you are using it in latex style, you can go with PDF or SVG. Or else if you are using it to a PowerPoint presentation, you can go with PNG style and anything in between. So let's first look at the PDF side. So I will select PDF. Note here on the top, when you're exporting, you have few options like the document, page, selection, custom. So now I'm in the selection since I have selected my circuit. And here, this is your path of the directory, basically, where the PDF will be saved. It is your project folder. And then you click export. So when you open up the PDF, it will look like this, and you can zoom in however you like, and you will see how the quality and the clarity retains. Just like this, you can actually export it to any other format you like. You can have certain templates built. Like for example, I had a template built for the IR emitter and receiver package. So whenever a circuit needs that, you can just copy and paste from that template. So that is the easy part. Like even for LM311 IC, I have a LM311 IC template which I have saved. So whenever I need to use the LM311 IC, I don't need to redo it. I just need to copy and paste the existing one. So hope this video gave you a brief overview into the development of electronic block diagrams, high quality electronic block diagrams using the free open source software of Inkscape. And there are a lot of unknowns in this software. It takes a lot getting used to. This is not a, I will not call this a user friendly software. It is, there's a very steep learning curve to this software compared to its alternative like Adobe Illustrator. However, this is free, this is open source, available across all platforms, and once you get used to it, this will be one of the most convenient ways you can develop not just electronic block diagrams but any form of scalable vector graphics. So hope you enjoy the video. If you have any questions or doubts, you can let me know in the comments below, and any iterations of the videos you need, maybe control systems block diagrams or any other forms of content that you need, feel free to let me know and I will try to do a video on it. Thanks for watching.